Hi guys, I'm going to go over topic 16, SAS 4 part 1 in a little bit of a different way, not really, just to kind of reinforce what you just watched. So first of all, we're going to take a look at what is factoring. And I'm just going to use simple numbers like this, 6, 15, 8, and 20. So basically, factoring is turning a number or an expression, these are actually all considered expressions, into factors. In other words, into numbers that multiply to make that expression. So, for example, if I was to factor 6, what two numbers multiply to make 6? Well, I hope you know that it is 2 and 3. So to factor 6, we would write 2 times 3. This is called the factored form. Okay, so really that's what we're doing in this chapter is we're factoring, but we're going to be doing it on more complicated expressions. Let's do 15. 15 is 3 times 5, so we would write 3 times 5. That is factored form. Now for 8, I would have 2 times 4. Now notice that 4 can be factored again into 2 and 2. So factored form would be 2 times 2 times 2. And another way we can write that is 2 to the third. For 20, we would have 4 times 5, or you can also do 2 times 10. It really doesn't matter. You're going to arrive at the same answer. And then for 4, we're going to have 2 and 2. And so factored form would be 5 times 2 times 2 in any order. It really doesn't matter. And then you can also write 5 times 2 to the second power. That's fine also. So basically that's factoring, but we're going to be doing it for a more complex expression than just numbers like this. We're going to be working with algebra tiles. And I just want to go over what they look like. So here we have x squared, and on the back we have negative x squared, but we're not going to be using this side. We're just going to be using x squared. And here is the x tile, and the red side is the negative x tile. And then the positive 1 tile is the yellow side, and the negative 1 tile is the red side. So those are our tiles. All right, let's get going. So once again, we are on topic 16, SAS 4 part 1, and we're going to be working on all the problems for number 2, and I'm going to go over how to do this with algebra tiles. So notice for 2a, it says x squared minus 4x. So the first thing I'm going to do is I'm going to find algebra tiles to represent this expression. So here I have x squared, and minus 4x would be 4 of these red tiles. Now, the goal here is to make a rectangle. If you can make a rectangle, you can factor. So the easiest thing I'm looking at right now is just to squish these together, and there's my rectangle. Easy as that. Okay, so what do I have here? Now remember, this is an x squared. So this is an x by x. Now, over here, these are all negative 1s. Right? So how much is that all together? Negative 1 times 4 is negative 4. So this expression up here is x minus 4. And the expression over here is x. So I have x and I have x minus 4. So to write it in factored form, I have x times x minus 4. And I'm done. Here I am on 2b, and I have the expression 6x plus 3. So the first thing I'm going to do is I'm going to get 6 of the green pieces. Remember, those are all x's, and I need 6 of them. So here I have 6 x's. And I also need plus 3. So here's 1, 2, 3. Okay, now remember, something I forgot to go over with you guys is, remember, the first goal is to see if there's a GCF. So that's what I'm going to do first here, is to see if there's a GCF. In other words, is there a way I can group these guys into different groups? Well, let's see. Let's see if I can make 2 groups. Well, here I can make 2 groups of 3. Here, there is no way to group these into 2 groups. So back to the drawing board. Can I group these into groups of 3? Well, yes, I can. So here's my group 1, group 2, and group 3. Can I do it with these 3? Yes, I can. I can put 1 here, and 1 here. So notice I have just factored it. Now this right here, this piece is 2 x's, right? These 2 are 2 x's right here. And this is a positive 1. So each one of these is 2 x's and a positive 1. So I have 2x plus 1 3 times. And I'm done. All right, so here I have a trinomial. And I have, let's see, x squared, so that's this piece, plus 5x, 1, 2, 3, 4, 5, and plus 6, 1, 2, 3, 4, 5, 6. Now, the first thing we need to do is look for a greatest common factor, but notice that there really isn't one. There's no way to group these. So the next thing I'm going to do is I'm going to try to make a rectangle. So my first inclination is to do this, right? But then I have these pieces. So I can put them here, because this is a length of 1, but I can't put this here, so I'd have to put it there. Now, that doesn't really look like anything to me. That's not a rectangle. So we have to start over again and think of another way to make a rectangle out of these pieces. So I'm going to move these out of the way and maybe break these guys up. So here, maybe I'll try 2 and 3. Okay, and instead of putting them all here, I'm going to put them down here. Okay, so that seems to be a good fit. Now let's see if I can place these pieces in such a way that would make a rectangle. Well, look at that. Perfect fit. Here's my rectangle. So what did we make? Well, up here we have x, and over here we have x. And over here I have plus 2. And over here I have plus 3, right? 1, 2, 3, and this is 1, 2, right? So I have x plus 2 times x plus 3. You can also reverse it and write x plus 3 times x plus 2. It doesn't matter. Because multiplication is commutative, so it doesn't matter. You can switch it around. And it's factored. That's it. Okay, here's 2D. I have x squared plus 6x plus 9. So here's my x squared. 6x is 6 of these. There's my 6. And then plus 9. Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I've got all my pieces. There we go. All right, so again, my first inclination would be to smush these all together. Okay, and that's not going to work because that's just not going to work. Okay, so yeah, that's no good, right? So let's break these up. So the first thing I would do is actually split these in two to see if that helps. It doesn't always work, but you know, that's the first thing I would try. All right. Now let's see if I can fit these little ones in to this space so that I make a rectangle. Well, look at that. Perfect fit. So what do we have here? We have x over here, and we have 1, 2, 3 plus 3 over here. And what do we have on the left? We have x again, and we have 1, 2, 3, x plus 3. By the way, this is called a perfect square. You'll notice not only did I make a rectangle, but I actually made a square because I have the same length on each side, x plus 3, x plus 3. So the way you factor this is you write x plus 3 times x plus 3. Or another way you can write this, since both of these are exactly the same, you can write x plus 3 squared. So either one of these is an acceptable way to write the answer. Here we are on to E, and I have x squared minus 4. So here is my x squared, and minus 4 are the red pieces. So I need 4 of those. So here's x squared minus 4. Now, again, we need to make a rectangle. Now, since we don't know how long this side is, we only know that it's x, which is a variable. I cannot put these pieces here because I'd be assuming that this is a certain length. So I can't put them anywhere along this side. It's not going to work. So really, they have to be kind of alone out here. So I'm just gonna make a square out of them just to make it simple. I know you can put them in a row, but it'll be easier if you make a square out of them. So this is what I have right now. Now, obviously, I can't make a rectangle right now. What I need to do is I need to bring in 0 pairs. Now, what 0 pairs are pairs that will cancel each other out and make zeros, but will help us complete our rectangle. So for example, a 0 pair might be this. A 0 pair might be this. Okay. You can also have a 0 pair of these guys if you wanted to. That would be a 0 pair, but we don't need these huge squares. So what do I need to fill in right here? Now, obviously, we can't use these guys because we don't know how long that is. But we can use these because the length here is also x, and x would fit perfectly right there. So we can't use those. We have to use these 0 pairs. Well, how many 0 pairs do we need? Well, let's see. If I take 1 pair and I put them right there, that fulfills this side of my rectangle. Now, what do I need down here? Well, if I put another pair of 0 pairs there, then I've completed my rectangle. The only thing is, this rectangle is really messy. I don't want it to be red and green and red and green. That's very messy. So what I'm going to do is I'm going to take the red out of here, and I'm going to take the green out of here, and I'm going to pair them together so that the same colors are together. Okay, so now I have 2 reds and 2 greens. Now notice that the 0 pairs helped us complete our rectangle, but didn't change the value. It's still x squared minus 4 because these 2 right here, these add up to 0, so they don't count. all right, because they're going to cancel each other out. So what do we have here? We have x, and then this right here, this is minus 1, so that's minus 2. And over here, we have x plus 2. So how do I factor this? I have x minus 2, and I have x plus 2. And it is now factored. Now moving on to number 11, which was at the end of topic 16, SAS 4, part 1. It should be at the last page, 11 and 12. That's what I'm going to do next. So here I have x squared plus 6x. So here's my x squared, and I need plus 6x, which is 6 of these. All right, so here's x squared plus 6x. I cannot chop this thing up, so I can't break this up into groups. So my first inclination would be to make this into a rectangle. So again, I always think of squishing it together first. And here I have squished it together, and it's a rectangle. So great. So now I have x, and then over here I have plus 6. 1, 2, 3, 4, 5, 6. And on this side, I have x. So how do I factor it? X, that's this x, and then in parentheses, times x plus 6. And I'm done. Here I am on number 12, and I have 2x minus 12. So that's 2 of these, that's 2x. And negative 12 is 12 of these red pieces. I'm just going to add a bunch of them and see if that's enough. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We don't need that one. Okay, so here I have 2x minus 12. Okay. Now, again, my first thought would be to turn this into, well, actually, no. Yeah, we could turn it into a rectangle, but the first thing would be, again, to see if we could find a GCF here, because I'm seeing a GCF. Can I split this up into groups? Well, I only have 2 of these, so my choice is only 2 groups. Can I split this into 2 groups and this into 2 groups? Let's see. Here's 1 and 2. And how do I split 12 into 2 groups? Well, it should be 6 and 6. So 1, 2, 3, 4, 5, 6 on that side, and then 6 on this side. So what is this right here? Well, this right here is an x, and this is a negative 6. So I have 2 groups of x minus 6. So both of them are called x minus 6. This is x minus 6, and this is x minus 6. And there's 2 of them. And I'm done.